How did you grow up? You grew up in Hong Kong, and how did you get interested in whatever ended up, in your field right now?
All right. I grew up in Hong Kong. Hong Kong was a British colony at the time, and most people in Hong Kong were rather relatively poor. At the time, it was like a developing, it's not a country, it's a colony. It's a developing society. And most people were not very well educated at the time. In my parents' generation, they all got clobbered by the war and the World War II, and the education were interrupted, and many of them don't formally go to school. And both of my parents did not finish high school. And but they were just like many Asian parents. They are very adamant that all the children should be well educated, and that's what they put the emphasis on. So I went through a very grassroots type family. We live in very cramped apartments, and when I was at a very young age, we kind of won the lottery from the government, because at the time the government was building plenty of government housing,
high-rise
apartments that have that they rent out to the population at very low prices, low rent, and so we sort of won the lottery and moved into one of those, and that really changed our trajectory. And we stayed there. I grew up there in the housing project, and later on, as our family got a little bit more resources, we moved out to private housing. But the early years, we grew up in a housing project, which really immersed us into the general public of the society, which gave me a pretty good perspective of what the society is about.
Who would have put more premium on education amongst your parents? Was it your dad or your mom?
Both of them, because they didn't have a chance to go through formal education, and so they realized, and right after the war, everybody needs to make a living, so to speak, and so there wasn't much of an opportunity for them to get a formal education. So they are very insisting that everybody should in the family should be well educated.
How did you discover electrical engineering? I mean, you could have done other things, right?
Yeah, I could have done other things. That was, I guess, the society at the time gravitated towards STEM type education, because that seems to be a kind of like a ticket to a better life, better career. And the humanities and the arts are less well defined. For example, if you're licensed to become an engineer, then of course you're licensed to practice, you got a good career and so on. Whereas the other professions seems to be more nebulous and less well defined. And so a lot of the kids at the time who did well in school tend to pick one of the STEM fields to go into, and so no exception for me. Follow the crowd and enter kind of go into a science type curriculum. And out of the science type of curriculum, the physics and the chemistry part of the science curriculum is more kind of quantitative and formal, and makes it easier to quantify, and at least for me, it's easier to understand. And rather than, for example, in biology, for example, it's more to me at the time, it looks like a more observational science. You need to remember a lot of things.
Right.
And I'm not very good at remembering things. So
you're being modest.
So the physics and the chemistry looks better. Now, when I was about to enter college or university at the time, the careers for people who study basic science is rather limited, because it's not a basic science research as in the US it is today, right? But being a basic science researcher is not a career in Hong Kong at the time, right? So most of the science type careers are more practical. Engineering is one of them. So many of our contemporaries becomes engineers. And out of all the engineering, the electrical engineering is closest to physics. And it uses many of the same concepts in physics, quantum mechanics and electromagnetics and so on. They're more closer to physics. So that's why I get attracted to it.
Yeah. I think it's probably safe to assume that countries or nations or governments or political cultures within each that would have put strong emphasis on STEM, they tend to have done well, as opposed to those that probably put less emphasis on STEM, right? Would you attribute this to the political culture in your household, or sort of like the pervasive political culture at any dimension, at any level? Or you think this would have been something that would have been driven by the leadership of that country, that nation, or the government?
I think if you talk about, if you look at many of the Asian countries, they have this strong emphasis on STEM.
Yeah.
And my crude understanding is that from an economic development point of view, you do need these skills. From an economic development point of view. If you want to build infrastructure, you need engineers to build the bridges and roads and so on and so forth. If you want to have industry, you need people who can do the engineering, mechanical engineering, electrical engineering, and so on and so forth. That's, I think, mostly coming from the point of view of economic development. But I should say that economic development in and of itself only takes you so far. At some point, their society will need things other than economic development, and that's where the humanities and the arts and so on comes in. That people in society are not just simply satisfied with the money,
right?
But beyond, there's a lot more than making a living. Once you are comfortable about making a living, then you look for something else. I think that is the part that a lot of the Asian countries may not have recognized.
I'm just, sensing that there's still quite a lot of countries that have not focused on STEM as much as some countries that we might have seen.
Why so?
Not sure. I mean, I'm in the camp that believes that I think a higher degree of focus on STEM is correlated with your ability to move marginal productivity, because that's correlated with innovation and all that good stuff, right? And being able to combine that with liberal arts or humanities, I think that makes it even more a good combination. But some countries, I think, tend to focus a lot less on STEM, and that I think has hampered development to some extent, and I'm just happy with how Hong Kong, has put a lot of emphasis on STEM, along with some other Asian countries, such as Korea, China, Japan, and now recently, you've talked about Vietnam and Southeast Asia, right? You can see that in the tenacity with which the people of Vietnam, I think, are focusing on STEM. I come from a region, called Southeast Asia, where I think the focus on STEM needs to be, more emphasized going forward. You went to Hong Kong University.
Yeah.
Then you decided to move to the US.
Yes.
Why?
Well, very simple. I am interested in kind of more advanced knowledge beyond the bachelor's degrees type education. I was looking for a place where I could get a PhD. At the time, it was in early 80s. None of the universities in Hong Kong are what you would call a research university. They're basically teaching universities. Just in the colonial days, the universities in Hong Kong meant to train bureaucrats for the civil servants in service of the government. and they're not interested in doing research. So there's really no opportunity to do any research in Hong Kong.
Yeah.
So I came to the US.
And it's worked out okay with you.
So far, I'm okay, I guess.
Now I want to shift gear to your area of focus. I mean, I know you're teaching electrical engineering, and you're one of the few people that understand the semiconductor, sector. Why is it called semi, not full conductor?
That's interesting. But before I get to that, let me just finish by your previous question. I think my kind of journey from Hong Kong to the US is a very typical journey for many immigrants who are in the technology field.
Right.
They got educated in their home country and came to the US, saw an opportunity to get better education, and then many of them do stay. And I think it's a very important source of talent for the US. And maybe we could come back to that later. But I think it's really important. If you look around in academia, in industry, many of them do come through this route of getting an advanced degree and ended up staying.
It's been the main source of innovation in the US.
Absolutely. If you look at top management CEOs of big companies, many of them come through this route.
Yeah.
And that's very important.
Yeah. Well, while on this, I mean, do you see that as something that's likely to continue, given?
I think that's in jeopardy.
Okay.
Given the recent,
the political calculus seems to be.
Seems to be the pendulum has swung to the other side in recent years, and you see a lot of soul searching about immigrants or foreign students and openness in research and things like that. And that, I think, that creates an environment in which, for a potential student from other countries looking at the US, and they would begin to think about whether this is the right place for them, or rather they would go to some other countries to get their education and the experience. When I was just graduating from college, that answer is very obvious. Where do you go? The US, of course.
Yeah.
But
now you've got optionalities.
Now you got options, and also not only options from a pull point of view, but from a push point of view.
Correct.
A lot of people felt that the US may not be so welcoming as before. And so I think that route or that flow of people is somewhat in jeopardy.
On the other question, why is it called semi?
Oh, why is it called semiconductor? I forgot who I heard it from when somebody talked about semiconductors, and somebody who's not in the field asked, why semiconductor? How come a full conductor is not better? Cup half full? Well, what is a semiconductor? A semiconductor is a material that, as its name implies, not very conducting, not very insulating, and somewhere in between. And why do I want something in between? It's because a full conductor would be something like a piece of metal, like copper or silver or that kind of thing, right? So a full conductor. Now, not a full, but a real conductor, basically. Why semiconductor? Semiconductor is used to build switches, like electrical switches, wall switches, flip on the switch to turn on the lights. And computers are actually a bunch of switches. We compute by designing the organization, arranging switches, how to route the switches around. In the early days, the telephone, you have a switchboard, and you have real people who connect one line with another that in a switchboard. And all these are replaced by chips today, of course. And so computers do computation by flipping switches, basically. So a semiconductor can be turned on to be conducting or be turned off to be not conducting. And that basically is what a switch is about. So semiconductor is used to build switches. And so that's why semiconductors are useful, because it can be turned on or turned off.
Gordon Moore, he came up with this prognosis decades ago that, things were going to behave in a certain way by way of the capacity growth, the speed growth. It's been very, very accurate.
Yes.
Right? Every year and a half to two, the doubling of the capacity and the speed. What's going to happen with Moore's law?
Okay, first of all, that Moore's law, which you refer to, doubling of something, initially he was just suggesting doubling the number of transistors on a chip. And later on, people modified it and double anything, which is not really what he meant, but people tend to associate it with Moore's law that way.
Right.
But that one is basically a self-fulfilling prophecy. And it's actually a rather unusual situation for a technology or for industry. I believe one of my colleagues, Professor Jim Plummer, said that he's not aware of any other industry that has this kind of self-fulfilling prophecy. And namely that everybody thinks that in X number of years, such things will happen.
Right.
And so because companies are competing, because there's a prediction out there, companies are trying to either meet or exceed that prediction so that you can be better than your competitor. So as a result of that competition to get to that particular goal, that goal is satisfied because of the intense competition. And also, that also not only just the desire to compete, but also having a goal allows everybody up and down the chain, the entire chain of events, from materials to device technology to circuit design and architecture and so on and so forth, up and down the chain to have a predictable cadence. Let's say I'm designing something. I need what I designed to be run on some kind of chip. Now, I cannot start designing the chip unless I know what the chip technology can do, what the capability is. Just like if you try to run a marathon, right. I cannot win the marathon unless I know what my capability is. So you need to know what the capability is before you can design your chip. Now, without that prediction, you wouldn't be able to say, I'm going to design this based on this assumption that the chip technology will give me this kind of performance. I cannot do that. But with this kind of self-fulfilling prophecy, I know in 2 years, the chip technology will advance to a point where I can count on that particular performance. And so therefore, I will tailor my design based on that assumption. And that's very powerful.
Very powerful. It sort of framed the behavior of the industries.
Absolutely.
Right?
Absolutely. Consistently for decades. Even that I gave the example of designing chips, even down to the material supplier. The material supplier knows that the chip manufacturer will need this kind of material or will need this kind of material to have that kind of performance in 2 years. So therefore, I work on developing it with the full knowledge that when I get done, I will have a customer. That's risk mitigation is very important. If I develop something, I spent millions, multi-million dollars developing something. I didn't know whether there's a customer. But that's bad.
Yeah.
But in this case, I know.
At the risk of quoting you in previous conversations, at the rate that the percentage of how the chips occupy our lives, if not lifestyles, at an increasing rate, whether it's opening your window in the car, turning on your toaster, turning on your microwave oven, whatever, before you get to the more complex stuff. What's going to happen to Moore's law? Is it likely to be more exponential than whatever we have seen in the last few decades?
I think there are two dimensions of it. Well, for short answer, yes, it's going to be more exponential.
Yeah.
Okay. Why do I say that? First, for the last several decades, we know that there's one way to improve the performance of the chips, which is to make it smaller. And there are a lot of physics involved and to explain why making it smaller is better. Right? So we know that there's one way, and we've been kind of turning that knob for several decades now.
Right.
And that knob has kind of saturated a little bit, just like anything else. You put the gas pedal, it hits the floor. Right? In the beginning, you're accelerating, but then pretty soon you hit the floor. Right? So that's for sure. But that doesn't mean that progress will not continue to be made, because there are many other knobs. There are many other ways to make progress. It's just the analogy I'd like to have is, for the past 50 years, we've been walking inside a tunnel. There's only one way ahead. We know what the goal is, and we just want to make progress. And to make progress, that's one. Making devices, making transistors and memory smaller will allow us to pack more devices on the same chip and therefore get more functionality, better performance, and so on. That method is the one method that we know, and that is saturating, but it's more or less like walking inside a tunnel. There's no way to go, it's the only way forward. But now we're at the exit of the tunnel. Now at the exit of the tunnel, there are two ways to interpret it. One, you fall off the cliff, you're just dead. Second is the world is open, wide open, no more confining. You cannot go left or right. You can go anywhere you want. And I think my interpretation is we're at the exit of the tunnel. There's so many possibilities, and we will continue to grow in capability in an exponential way, or even faster. Now, why am I so optimistic about that? Is because necessity is the mother of inventions. And my optimism arises from the fact that society demand more from these chips, not less. The society will demand more and more from semiconductor technologies, chip technology in the coming decades than we have done in the past few decades. So because it's coming from the demands, innovation will come up and bring the technology up in a much faster pace than before, because we are not confined by the tunnel anymore.
What could go wrong?
What could go wrong? Geopolitics could go wrong. Okay. I think that's a very important aspect that wasn't there just maybe like a handful of years ago. I think that is an important part, because research and development thrive on collaboration. And there are many, many examples. We can go into that a little bit more later. But it thrives on collaboration. And if geopolitics cause collaboration to not happen, then the rate of progress will be severely curtailed. I think is something that could go wrong.
You know, we're going through this era of what I call multipolarity, right? And I've said it before that, ironically, in a multipolar world, multilateralization becomes more difficult, because there's this tendency of revisionism by the new middle powers or greater than middle powers, right? And the pre-existing superpowers are not comfortable in embracing this new mode of multipolarity. I want to put this in the context of what you've been affiliated with, TSMC, right? They've basically created a recipe for success that involved a lot of collaborative undertakings, right? From a supply chain standpoint, from a research and development standpoint, from what have you, not just amongst enterprises, but also between academia and policy making and entrepreneurship, right? What made them the way they were or they are?
I think your observation is extremely astute in the sense that a lot of people think a company like TSMC is a collection of factories and tools,
Right.
or even just factory workers.
Yeah.
And that's about it. But really, it is not. It is a enterprise that involves a lot of collaborations, that thrive on the network of customers, network of suppliers, network of collaborators in research and development, network of collaboration with the broader society in which they lives in,
right,
the Taiwan society. It is a network of all these things, and even more, perhaps, I didn't go into. So that piece, that collection of relationship is what makes this company the way it is. Let's say we all of a sudden transplant this company to another country or another place that doesn't have the same political economic system. It is highly questionable whether they can continue to operate the way it is.
Yeah. So how do other countries try to replicate just any bit of what TSMC might have been able to do? And I'm not singling TSMC out here. There have been others that have been legendary and great, right?
Yeah.
The Samsungs of the world, the Intels of the world.
Absolutely. Yeah.
But I think TSMC has proven itself to be very resilient and very different. And their success seems to be sustainable so far.
So far, yes.
Right? And go back to the history of how it came about. Go back to that conversation between Morris Chang, the legendary Morris Chang, with, somebody or some people in Taiwan that made it the way it has become.
I think there are two, if not more, at least two very important elements. One, technology competition is really a talent competition. First, talent. Yeah. Second, the broader society's support of the industry, not just the company, but the industry itself. You need a infrastructure for the company to exist, and suppliers, customers, and so on. So let's talk about talent first.
Right.
Taiwan in the early days of the 60s, 70s through the 80s and 90s have sent, well, it's not that the government sent them, but students from that era, all after they graduate from college, they all went out to the US, to Europe, outside of Taiwan, who has more advanced education achievements in the universities to get education. And many of them stayed in the local host countries to gain work experience. And in time, many of them go back to Taiwan to continue the career for a variety of reasons. Sure. Want to be closer to home. And I guess that's maybe perhaps one of the biggest draw, be closer to home, or perhaps a perceived better career opportunity in the home country. So like playing in the home field, right? So which people sometimes feel more advantageous, and knowing the culture and the people well. So talent, the flow of talent is one of the most important things. If you look at the leaders of the tech industry in Taiwan today, many of them were educated in the US through this route, getting educated in college, go to other countries, the US, Europe, and so on, and go back to Taiwan, have a work experience, go back to Taiwan, bring the work experience, bring the knowledge with them. And that is very important. That is, I would say, perhaps is one of the major ingredients for the success. And it's not just limited to Taiwan, Korea as well.
Yeah.
We look at the many top management in Samsung and Hynix and so on. Many of them were educated in the US. So that's one part of it. But that's one piece. But the other piece, which is important, is support of the society. If you think about how the semiconductor industry was started in Taiwan, it was really supported by the government. It's industrial policy, basically. The Taiwan government decided that this is an industry they want to get into, and they supported with building industrial parks, with starting ITRI, the Industrial Technology Research Institute, which spun off TSMC and many other companies as well. So the government really had a really robust industrial policy. Now, of course, industrial policy may or may not succeed. If you bet on the wrong thing, that's bad, right? And that's really, of course, if you're in the U.S., you know that the U.S. feels that they don't need an industrial policy, right? And we don't go into that. But in this particular case, industrial policy worked out for them. And the government really supported it, building industrial parks, finding other pieces of the puzzle to fill in the infrastructure for the semiconductor industry, and also basically the technology industry. Back in the 80s and 90s and early 2000s, Taiwan basically manufactured, but basically it's the world's manufacturer for PCs and
everything, even bicycles.
Bicycles as well, yeah. And so the government really supported it with really strong industrial policy.
That's amazing. Now, in early days, a lot of the intellectual property with respect to the microchip technology was done in the U.S. Do you think that with the benefit of hindsight of the U.S. were to decide otherwise, meaning they would have wanted to onshore the manufacturing capabilities as opposed to offshore the manufacturing capabilities, would things have been different?
This is a very complex problem that I've been thinking about more recently, and I haven't come to any reasonable resolution or answer yet. And I can tell you what the kind of disconnect or problems are. One is, in the US, as I said, this is a technology competition, it's a talent competition. If you look at the cost of talents in Asian countries and in the US, the cost differential is pretty high. Right. So it's
getting smaller, but back then it was huge.
Oh, it was huge. It was huge, right? So to get talented people working on hard engineering problems in, let's say, in Taiwan or in Singapore or in Korea is way less costly than it is in the US. So in other words, they could deploy many high-skilled talents to solve engineering problems, whereas the US is at a disadvantage in terms of cost. Not capital cost, but just talent cost, right? Give an example. I recently went through more than 20 years of TSMC annual report. Every year, they report on the education level of the employees. Starting from 1999, about 40% of the employees have a bachelor's degree and above. Today, 80%.
Wow.
Now, that coincides precisely with the steady climb in the technology ladder, the leadership race, the steady climb from beginning. They were licensing it from RCA, licensing technology from the US, and bring it back to Taiwan. Gradually, they learn how to do things themselves. And the way to do that is to get talented people. So they started from 40% people, employees who has a bachelor's degree and above, to today, 80%. And so that really tells you technology competition is a talent competition.
Yeah. Okay, in this context, which other countries do you think have done as much or just about the same amount that Taiwan has done? And I mean, when you think about talent, you think about human capital, you think about countries that have shown, right, abilities to project intellectual capital, right? Within Asia or within the world, which countries do you think are likely to be able to emulate the kinds of successes that we've seen in Taiwan?
Well, I've seen like countries like Singapore, Korea have been tremendously successful.
Yeah.
Right? Korea, I remember back in the 60s and 70s, Korea was nowhere to be found.
They were nowhere,
right?
Yeah.
And then later on, they have kind of Me Too type products.
Right.
And we associate those
you
kinds of
usually
products.
start out with Me Too's.
Yeah,
then you start
with Me
being
Too's.
innovative and unique.
Exactly.
Right.
And then slowly they climb up the learning curve. And I remember years ago when you see Samsung, I said, what the heck is this?
Yeah. Well, now it's
not
very
reliable.
different.
Now it's the best thing in the world. Right? So these countries have done quite well.
What about China?
China is, I don't think we could ignore their capability. They have, let me talk about something that I'm familiar with, just research.
Right.
I'm academia, I know
Yeah.
research. Years ago, we have technical conferences and we see papers from China and say, forget it. Just quality is so bad. It's not even
Now
competitive.
it's very different.
Now, that was probably in the 80s and the 90s. Now, they're better than us. They're better than us. If you look at, I've looked at papers, publications, data from key conferences in the chips business. For example, in the International Electronic Devices Meeting, which is a device technology conference, the biggest one in our field. International Solid-State Circuits Conference, the Circuits and System Conference in our field, the two biggest conferences in our field. You basically flipped. Years ago, the U.S. had the majority of the papers. I remember there were roughly about 40 to 50% of the papers from the U.S. And China, maybe 20, 30 years ago, there were nowhere to be found. Today, China and Asia, the papers are more than 40%, almost close to 50%.
Oh my gosh.
And the US has steadily declined from 40-50% to 30-40%. And the rest of the world, principally Europe and Japan, has basically fallen off the cliff. So the research and development, the research capability in Asian countries, China, Korea, Taiwan, Singapore, and so on, have really become the strongest region in terms of producing good quality research. I'm not just talking about quantity, just quality. And the only thing that I see that the US is still a little bit ahead is in coming up with the new ideas. What the Chinese always say, going from 0 to 1. Namely, starting from nowhere, nothing, and come up with this really new idea. And if I look at what I would call new idea that is not been discussed before, the U.S. still, if you read the research papers, the U.S. still is the principal place where these new ideas come from. But once these new ideas become known, then
you see mushrooming of this New ideas in other places.
Exactly. And I feel it in my everyday research with my students.
Oh my gosh.
Any new ideas that we come up with, once they become known, this is a good idea.
The next week it will show up in China.
It will actually show up in China. Not only that, they do it better than you.
Yeah.
I cannot compete anymore. They have better resources. They have more students. They have more funding from the government. I cannot compete anymore. I have to get out of that field.
I want to get back to this, but I want to ask you about two countries like India and Israel. I mean, they have tremendous human capital, right? Do you see them as contenders in being able to, replicate the kinds of successes?
India has tremendous potential. It's tremendous potential. Their human capital is unbelievable. Not only they are a very populous country, of course.
Right. They got scale.
They got scale, right? And the statistics work out for them, right? When you have scale, then there are going to be outliers who are really smart and very innovative and so on, just like China, right? So that they have. That's very important. I think they have tremendous potential if they do things right, because they got scale. The people are smart, right? And in terms of Israel, they don't have scale. They're a small country, but they are smart people, obviously. The difficulty they have is lack of scale.
A bit like Singapore, then.
Yeah, a bit like Singapore.
Okay.
Right. In Singapore,
a lot of smart people.
5 million people.
Yeah, 5.5.
Yeah.
That's finite.
Yeah, finite. Yeah. They don't have scale.
Going back to China, with the advent of AI, how do you think the speed of new ideas creation is going to be impacted?
I think the speed of new ideas...
you can get AI to create a paper, right? Pretty much.
Yeah, but I think ideas still come from people. It's the acceleration from an idea to something useful that AI will be able to help with. The ideas still come from people, but today there are a lot of barriers and times and efforts required to bring some idea to fruition. Perhaps the advent of AI would shorten that life cycle, but the ideas still come from people, I believe. Now, AI would really help with the US and more advanced countries to get back into the game of manufacturing. Let me explain why. I mentioned earlier that the cost of human capital is, you cannot ignore it. The differential is there because of the standards of living and so on and so forth. It's there. Now, with AI and robotics, we should be able to make a lot of progress in advanced manufacturing, because in advanced manufacturing, you need many high-skilled people, because those manufacturings are so complex. It's not like repeatedly doing things over and over again according to a recipe. You need to be able to understand the process, improve on it, and those require high-skilled people, highly educated people. Now, the developed world have a very high cost for human capital. That being the case, you want to make really good use of those people. Those productivity has to be much higher. And the advent of AI, robotics would allow developed countries to deploy these highly skilled people much more effectively than before. And so using that would allow us to level the playing field a little bit about the cost of high-skilled labor.
In the next 10 to 20 years, how do you see the landscape of the competition? In terms of countries. I mean, I think China is definitely pouring a lot more money onto this. The United States seems to be wanting to put more money onto this, not just on the IP side, but also on the manufacturing side. Mm-hmm. Korea seems to be very tenacious, right? How do you see the landscape?
It's
It's a bit like a Sputnik moment.
Yes.
From a chip standpoint.
Yeah. And not only chip, but many technology as well.
Right.
Many other technologies you can think about, like, electric vehicles,
right.
batteries, and so on. They're all like that, right? So the world is becoming a little bit, the world of manufacturing or technology becomes a little bit more polarized, right? So you kind of separate into two camps or 2.5 camps and things like that.
Right.
And people some countries will need to play both sides and find their way around. But generally speaking, we think of it as two camps, right? Now, that being the case, then, as I mentioned earlier, for technology to advance, you really need open science. You need collaboration. So now, being that there are two camps, they don't talk to each other, that means things are going to go slower. What does that mean? That means the society is going to benefit less because things are going to go slower. All right. Second is the separation of the supply chain, costs will go up. Right? You need to find your suppliers, not the lowest bidders, but thinking about geopolitical situation. So cost is going to go up. Now, the question is, who's going to absorb those costs? And it's not clear who's going to absorb those costs. And today, if you look at, in part, why manufacturing in the US is such a bad situation today is, in part, I believe, I'm no economist, I'm just guessing. I'm an engineer, right? So maybe an economist listening to this podcast would say, wait a minute, what's this guy talking about, right? But my guess is that the distribution of profits is not equitable across the entire chain. The companies who are operating at the top of the food chain, they glean most of the profits. I'll give you an example. I was just at Western Digital the other day, and they told me that if you want to buy an iPhone with more storage, they charge you $100 or $300 more. But the people who make the chips to make it happen get a few dollars. So
you were talking about level playing field,
right? So
there's not a lot of equity there.
There's a lot of equity there, right? So this situation needs to be corrected. Otherwise, the manufacturing in the US is not going to go well. I remember, for example, we talk about talent, right? I was once in a panel discussion with a bunch of semiconductor companies, and one person from company lamented that, we couldn't hire people. There's nobody wants to join my company. We have positions we need to fill, and so on and so forth. Lack of talent, lack of workforce. So I asked him, how much do you pay them? And he went silent. He couldn't answer my question.
Wow.
Why? Because they couldn't pay them to compete with the other people who reaps the profit, right? And because they couldn't pay them, they couldn't get enough profits, so that's why they couldn't pay them, and so they couldn't hire the people.
So this scarcity of talent is really structural.
It is structural. Right? It's not so much. A lot of people thought that, we just need to tell the universities to offer more courses. No.
Not going to happen.
Not going to happen. You need to have the demand. I could offer 10 courses, but if nobody take my course, it wouldn't help you at all, right? You need to have the demand from the students. And where do you get the demand from the students? The students need to know that they have a bright career in front of them if they take these courses. If they go into this field, they will have a good career. Today is not the case for many of these manufacturing related jobs.
So you're suggesting, if I get you correctly, there's likely to be a deceleration
yes.
of the competition by way of the polarization.
If we
And-
haven't managed it right.
Right. Well, hopefully we'll manage it better, right? And also the scarcity of talent.
A scarcity
Which
of
is-
talent.
I think it applies on both sides.
Yeah, exactly.
Right?
The scarcity of talent is
It's not just on this
because-
side of the Pacific. I think it's on the other side of the Pacific too.
Exactly.
Given the scale, of course.
Exactly,
right?
exactly. And that has to do with how the profits are fairly shared,
Right.
because the companies who are doing the manufacturing and all the things below in the supply chain are not getting enough profits
Yeah.
to offer good compensation, to offer good working environments to the
So
employees.
even within the supply chain, there's some players that are actually making disproportionately more than the other.
Oh yeah,
Okay.
oh yeah,
That's a structural impediment
yeah. It is.
to the desired speed with which you want to move.
It is. I think the policy makers and the economists has to recognize that. Otherwise, it is structural.
The aspiration to onshore
Mm-hmm.
in the US,
Mm-hmm.
there's been some conversations, discussions, and initiatives for TSMC to build a plant
Mm-hmm.
here and there in the US, including in Arizona.
Mm-hmm.
Do you see that moving smoothly or as smoothly as aspired? Or
Well, I was at this big conference in December. I told you earlier, a few speakers conference. I saw all my colleagues from around the world, from Europe and Japan and so on. My Japanese friends are all laughing at us. You guys are the slowest.
okay, that's public knowledge, I guess. Wow. Now, talk about, there's the logic chips, there's the memory chips, and there's the special chips, right?
Mhm.
We call it discrete or whatever. How will that fare going forward in terms of who's going to be more dominant than the others within each one of those three categories?
I think those three categories, they're all important.
Okay.
Yeah, it's not like one is more important than the other. They're more important. Like, for example, we're doing this podcast, right? You need computers to crunch the data and
Right.
stream the thing out.
Oh, and to store it too, somewhere.
Yeah.
Up in the
And you need
clouds.
storage to store it, right?
Yeah.
And the microphones, the video cameras, they all made of chips. Those are specialty chips,
Yeah.
right? So they're all important, right? And so we couldn't say, oh, we can just do without one of them. No, we cannot. They're all important. Now, as far as resources goes, as of today, the development of logic chips requires the most of the resources, because they are the ones who are driving in our kind of industry's parlance is the technology driver. The requirements drive the development of new technology, new equipment, new processes, new materials, new devices, new design. Those applications drive with AI, it drives big computers that can crunch these numbers for the AI models. And it also drives the development of computing chips that are so energy efficient. You can do things on the edge, what they call the edge of the internet. You go buy a VR AR headset today, you have to have a battery pack to come with it. And it's not the end state of VR AR headset. I'm pretty sure about that. Right? In the final analysis, VR AR headset is not going to operate like that.
Yeah.
But this is kind of like the intermediate stage that you need to go through. Just like cell phones used to be like size of a brick.
Yeah.
Right.
I
And
remember those.
you remember those,
Yeah,
right?
in the
And
early 90s.
In the early 90s,
Yeah.
right? And those can only make a call and cannot do anything else.
Right.
And I will tell you a story. When I was at IBM, I used to work on image sensors. And in the mid 90s, I had an idea. I filed an invention disclosure about putting a camera on a phone, on a cell phone.
This was in the 90s, right?
It was in the 90s. And the IBM lawyers said, Who wants a camera with a phone? We're not filing this
Say
time.
no more.
So, after like months, I finally convinced him to file it, and we do have a patent on that.
They had a great ability of prognosticating about the future.
Right. So all these things, all the progress that we desire the chips to have, we desire the chips to have this capability today is driven by computing means. But it doesn't mean that it will continue to be the case. It doesn't mean that. And also it doesn't mean that there's no real need for innovation in other places. For example, just take image sensor, for example. Tremendous innovation in image sensor. And they offer new capability in VR headsets. You need to have new innovations in image sensor and the way they receive the signal, convert it, and do processing right up front, not right at the sensor end and not back in the mainframe computer. So all these innovation needs to happen in order to kind of satisfy our society's demand for technology in general. If you look at, for example, the 17 Sustainable Development Goals of the United Nations, I basically go through all of them and say, hey, at least
Most
12, 13 of them require advances in computing technology and chips technology in general. So without those, all those development goals will be severely curtailed.
The backers of all these are consisting of the designers and the manufacturers, right?
Yes.
Now, the Qualcomms of the world, the NVIDIAs of the world, they seem to be content with just designing, right? How do you see the progression going forward, or the shifting going forward? Are you likely, or are we likely to see them moving in the direction of manufacturing, given the complications or potential complications that we might see in the context of this polarization?
Wonderful observation. 30 some years ago, when Morris Chang came up with this split between fabless, namely companies that only design and do not have any factory for building chips, and foundries focus on building chips and not designing anything, that demarcation, that split, caused a blossoming of design activities, because people who design do not need to own the capital and all the baggage of owning a factory. And so they could then specialize on doing design. At the same time, people who own the factory can specialize on running the factory, and also having the benefits of having zillions of customers instead of one customer. If I manufacture my chip, I sell my chips directly to the customer, then I need not only one customer, that's myself. That's not enough to have scale, to have this economy of scale for the manufacturing. So this split has really blossomed in terms of making the design ideas go a lot faster than before, and created a lot of business opportunity that did not exist before. Because previously you have to have tremendous capital investment before you can design your own chip. Now you don't. You just have to design and somebody will make it. Now that split has gone on really well for the last 30 some years. But today, if you look at the fabless and the foundry, they're not really split. They're actually together. Companies like Apple, Qualcomm, NVIDIA, AMD, they show up at the foundries every day. They tell the foundry, hey, run this wafer, try this experiment, show me the results, give me the wafers so I can test it myself. So they are actually doing a lot of the development work of the chip itself. So the leading edge technology basically are today co-developed between the foundry and the leading user. Whoever placed the largest order have a big say in how the technology is going to be designed and optimized.
But what about skin on a game, though, in terms of manufacturing capabilities? Are they likely to put more skin on
It
it?
seems to be the case. There are indicators in there already. For example, Sony put in money in Japan and kind of work with, collaborate with TSMC to build a factory. In Europe, the collection of automobile companies putting their money down to build a factory there. So you're seeing some of that. And how far it will go is not clear, but you beginning to see some of that.
Talk about this company in Amsterdam or in Netherlands, ASML.
Mm-hmm.
They make a pretty fancy technology, right? Ultraviolet lithography.
Yeah.
That's well needed for a bunch of things, right? Talk about that.
Oh, that's
history.
A technology marvel. Yeah. If you go into the details of how this machine, the EUV machine, the extreme ultraviolet lithography machine, is really an engineering marvel. Now, it is also a statement about two things. One, it's a statement about a global supply chain. The laser come from San Diego. The lens is polished in Germany. The mechanical movement came from Connecticut. So it's not just the Netherlands. It's a global supply chain of not only the machine parts itself, but also the knowledge, a global supply chain of knowledge. That's one. The other one is an example of open science. The first EUV papers were published in the late 80s by a group at Bell Labs, and then followed by a bunch of conferences in which researchers in Japan and in Europe all participated. And those and then the US national labs participated in the development of the early prototypes in the Department of Energy, the national labs. All these, and then companies start coming in, Intel, TSMC, and so on, and start investing. And we're talking about global companies, right? Not just one country, global companies investing in it. And years later, 30-some years later, or maybe 40-some years later, you have this wonderful machine. And that's all coming from a global collaboration of researchers, generating knowledge, sharing the knowledge, and bootstrapping from themselves. And that's a very important lesson for us to learn, is that if you cordon yourself off from the rest of the world, you wouldn't be able to achieve that. Or even if you are able to do that, it will take a much longer time, and you lose the window of opportunity. That's a very important lesson to learn in this day and age of geopolitical tension, and everybody wants to kind of have everything to themselves and not sharing with each other. If you don't share, you don't gain. You gain back more than we share. I think that's basically how I would characterize it.
You breed a sense of optimism just by way of how the intertwining of different stakeholders in multiple countries. You seem to suggest that serves as a structural, cohesive force for that to be it's very difficult to rip it apart.
Yes.
Right?
Yes. And if you do rip it apart, you lose.
Everybody loses.
Everybody loses. Yeah.
Yeah.
Everybody loses.
But, given the fact that we're seeing so much political neurosis in many parts of the world, right? Sometimes people don't act rationally.
Yes.
They act based on what their heart tells you, not what their brain tells you. Isn't that a risk?
Yes, there's a risk. I think in some parts, I think is due to the lack of understanding rather than any bad intent. It's not because somebody's bad intention or anything like that, but I think it's more like a lack of understanding. I came to that observation through my participation in a study from the Hoover Institution about 2 years ago. They had a study about U.S., China, Taiwan, and semiconductors. And they published, after 2 years, they published a report called Silicon Triangle. You can go on the Hoover website and download it. And through that participation, I understand, my observation is that many of the people in the policy circle, they don't understand the technology.
Yeah.
Therefore, because of this lack of understanding, they would make policy that really doesn't make sense from a technology. If you do have this technology underpinning, it doesn't make sense. Now, it doesn't mean that the people making policy meant bad or anything like that. It's just a lack of understanding. And it also doesn't mean that the people making policy are dumb or anything like that. It's not. Nobody understands everything under the world, right? Today, they may be making policy about the pandemic, and tomorrow they may be making policy for semiconductor chips, and the next day maybe nuclear arms, right? So there's no way anybody, any single person or even a group of persons can understand everything under the world, right? But I think policymaking would really be helped if there are more people who have domain expertise are participating in the formulation of the policy. And today, I think we have very few people who understand, at least in the semiconductor space that I'm familiar with, who are materially participating in the formulation of the policies. And I think that is a big hole that we need to fill.
Do you suggest a higher degree of cultural interaction?
Oh, yeah, absolutely.
Right? I get the sense that people are not spending enough time in each other's places.
Absolutely. Yeah.
Right?
Like I said, while I was participating in this Hoover study, many of them are policy people, China experts, and so on. And at the end of the study, we all understand a little bit more about what the other people are experts about. I didn't know anything about China policy or industrial policy before, but I have at least some introductory understanding about it by now. And my colleagues likewise have some introductory understanding about semiconductors. They wouldn't ask the question, why not a full conductor anymore?
I had to ask you that. and I gotta ask you, what's the difference between oil and chips? I know you've been asked that. What's the difference between oil and chips?
What's the difference between oil and chips? Yeah, that's right.
I mean, people have been saying chips is the new oil.
Yeah. So I participated in this Hoover Institution study, and a lot of people say, chips. We need chips, and chips are everywhere. Anything that you need to turn on the power, have a battery in it, or plug into a wall, involve some kind of a chips. You roll up your car window, there's a chip. You listen to a podcast, you need a chip. Everything is a chip. So it's like commodity. It's like oil. We need oil. We need fossil fuel, right? So people make a comparison between oil and chips, and that comparison is pretty prevalent in a policy circle.
Right.
Okay. Now,
but it's misplaced.
I think it's totally misplaced. And when I made that comment at the study, and people look at me and say, "Oh yeah, okay, why is it different?" Chips are a lot like oil because oil has been in the ground for millions of years. It never change. You dig it up today, you dig it up tomorrow, it's the same oil. The method of digging may be different, but the oil is the same. Chips are not. You have phones, you have watches, you have your TVs. Would you like to use a phone that was made 20 years ago? Would you like to watch a TV that was made 20 years ago? You don't, because chips constantly advance, and it has to constantly advance to show its value. People expect chips to continuously advance in its capability. Capability broadly defined as in amount of things, the kind of things that they can do, and also energy efficiency. Don't burn up so much energy or power. Don't use up that much battery power, and so on. So the chips is useful to us because it's valuable to us because it advances constantly. It constantly renews itself. Chips today is different from chips tomorrow. You want the chips tomorrow, not the chips of yesterday. Now, oil, it's not the same. You can stockpile oil, no doubt. And America does that. Many countries do that too. You don't stockpile chips. A stockpile that you have is not useful very soon.
Every couple of years, they're going to be obsolete.
Yeah, every couple of years, obsolete. Yeah, exactly.
Is it feasible to attain chip sovereignty or an absolute chip sovereignty?
Given the nature that we just talked about, the global nature.
I know, I'm imagining.
It's not possible. It's not possible. I think whoever suggests that put in a policy circle is probably not having enough understanding about how the thing works.
Then I got to ask you the following question. In the worst case scenario, where we're seeing some unintended consequence or episode, happening in the Taiwan Straits, what would happen?
Well, let me quote two sources. One, according to a McKinsey report, it would be worse than the pandemic economically. Second, you probably have seen the interview on TV of the TSMC chairman, Mark Liu. Question was posed to him by the reporter. And I would like to quote his response. Say, if such a thing happened, you have more things to worry about than just chips. Just make sure that it doesn't happen.
I'll pray.
Let's make sure it doesn't happen.
Well, we've talked a lot. Any final messages, Philip, to people in Southeast Asia or anywhere around the world so that they can feel more optimistic about their becoming much more, positive and constructive about attaining STEM capabilities, hopefully some sort of manufacturing capabilities too, and being able to be collaborative with the rest of the world and all that?
Well, one of the things that turned out to be positive thing for kind of developing countries or countries who are interested in advanced manufacturing, generally speaking, not just chips, but advanced manufacturing, is that because of the renewed sense of sensitization to supply chain resiliencies and so on, there is more of a diversification effort going on right now, that these countries who are historical in the past haven't really participated in this space have a great opportunity right now. And that means they need to be prepared to take this opportunity that is opening up to them. And that means, taking from the Taiwan experience that I mentioned to you that we discussed earlier, that means talent cultivation and government policy to support it, and general society, local society to support it. In terms of talent, by the way, a lot of people talk about workforce development.
Yep.
I actually don't like that word that much. I like to call it talent cultivation, because it's really talent, not just workers who repeatedly do the same thing, but really people who can continually learn and try do new things and understand the things what they're doing and be able to improve on it. Those are what talent would do, right? Not just generally workforce in the traditional sense of the word. And the other aspect is this general society support of the industry. I'll give you another interesting story. TSMC wanted to build a new factory in Hsinchu, in the place where they have a lot of factories. And the government zoned a piece of land for them. Unfortunately, there is a temple, a historical temple in that piece of land. I read about this in the newspaper. So, and of course, temple is sacred, and nobody wants to move the temple. But then, at the end of the day, they decided that, okay, I can relocate the temple for you. That's an important statement about how the general society support the economic development.
They know where the priorities are.
They know where the priorities are, right? And that's a really strong statement to support the society.
Let me ask you, with the benefit of hindsight, if there wasn't a meeting between Morris Chang and a public official who had the authority and also the vision, well, both of them had a vision, right? Would there be a TSMC?
Perhaps.
Yeah.
Perhaps. I mean, history developed the way it is because of certain events, certain people, right?
It's serendipitous.
Yeah. It's really, there's a Chinese saying that whether it's the situation that created the hero or the hero that created the situation, right?
Yeah.
I think it's a little bit of both. Right. Even if there is an official who started a conversation with a certain person, if that person is not astute enough, then there's nothing's going to happen. Or there's a very visionary person, but there's no corresponding government official who sees things the same way, nothing's going to happen. I think it's a little bit of both. And I think it's a little bit of both. And earlier you asked about any lessons about Southeast Asian countries. I think there's also a lesson to be learned in the US as well. In the US, we talk about onshoring manufacturing. To me, it sounded like giving a fish to somebody.
Yeah.
You haven't taught them how to fish.
Yeah, I agree.
Right. And that's important to understand. And the other thing is manufacturing and innovation or R&D, research and development, go hand in hand. Manufacturing is not just doing repeatedly the same thing to a recipe. There's a lot of innovation on the manufacturing floor. How to improve on the manufacturing process, how do you get better yield, how do you turn the current generation of technology a little bit better so that you can offer a newer version of this technology based on this current one. Just slight change, not big change, but slight change that provide value to your customer. How do you do that? And TSMC does that a lot. Every generation, they will come up with innovation on the manufacturing floor that turn it into a product that's slightly better than the previous one. That brings the customer in. You can tell the customer, hey, for a small price increase, you could get much better performance or energy efficiency or better cost that doesn't require you to go to the next jump. That's value to the customer.
Yeah.
So the manufacturing and research and development and innovation really go hand in hand.
Yeah.
That's one piece, one side of the coin. The other side of the coin is that research and development has to be really close to manufacturing. Otherwise, you're dreaming up with solutions that not manufacturable. And how do you know what is manufacturable or not? By being very close to the manufacturing floor. So in other words, it is very difficult to have the research and development divorced from the manufacturing. And so if we just say, hey, company X, just come to Ohio, Arizona, Texas, whatever, and build your fab, that's, I think, just basically isolate that so-called manufacturing from the rest of it. It's not going to be successful.
You got to be cognizant of the inseparability of the two components. Those are two sides of the same coin.
Those are two sides of the same coin. You cannot just say, I only bring manufacturing onshore and I don't do the R&D, and that's very important. So in other words, all these chips subsidies of $52 billion of
the
CHIPS Act, right? $39 billion goes to the manufacturing subsidies and $11 billion go to R&D.
Should be flipped.
Well, it may not be flipped because it takes more effort, more money to do the manufacturing, but the importance of which is flipped.
The R&D.
The most important one is the $11 billion.
I agree.
If you do that part right, I'm saying that not because I'm an academic, I do research, right? But if you don't do
I would
this
even
right,
put a greater number for R&D.
Exactly.
Than 11.
Right. That has to be done right. Otherwise, you'll get a fish and you ate that fish and then that's it.
You got to teach the fishermen how to fish.
Absolutely. And I think that is the most important thing. And for the fishermen to be successful, you need to be able to talk to other fishermen.
Yeah.
Where, so that you know where the fish is.
Yeah. And you got to have a boat.
Yes, you can have a boat, yes.
There has been a lot of rhetoric about friendshoring, reshoring, offshoring, right? In the last few years. But if you take a look at the empirical evidence, call it Southeast Asia, capital formation hasn't really moved up in a meaningful manner. And I would speculate or even hypothesize that a lot of that is because of the lack of investment on a human capital, right? And the onus is really upon us to get our act together. There is a desire to reshore. There is a desire to relocate. But if we're not ready, it's not going to come.
Yeah. Well,
and it hasn't come as much as we would have hoped for.
Yeah, to capture the opportunity, you need to be prepared. And this talent cultivation is really to be prepared. You look at China as an example. They graduate more engineers than anybody in the world.
Yeah.
And that's how they becomes a manufacturing hub of the world. And to go to Shenzhen, it's unbelievable. If you want to build something, some hardware, you got to be there.
Yeah.
They have not only the people, but also the infrastructure. Yeah. And the people is really amazing. They know how to do things. And so you need that investment.